We're in section 3-4's homework assignment in the textbook. Starting with number 1, fill in the blanks when solving this equation, 7t minus 57 equals 97. When you're going to solve it, first you're going to add blanks. So when we look at this, we've got the variable on the left side of the equation. We want to eliminate all the numbers. We save the one that's attached to the variable for last. So we're going to start with the minus 57. To get it to 0 and cancel it out, we're going to add 57. And then blank each side by blank. Now, if you noticed in the textbook answer key, they said multiply each side by 1/7 to get rid of this. Now that works, but that's not the way that we are going to talk about it. We're going to say divide by 7. This is 7 times t, so we're going to divide by 7. So divide, then divide is the first blank, each side by 7. But do know that multiplying by 1/7 reaches the same goal. It's the same thing. So dividing by 7, multiplying by 1/7 is the same thing. Dividing by 2 and multiplying by 1/2 is the same thing. So we want to make sure we understand that. All right, that was letter A. And letter B, we're actually going to solve and check it. So 7t minus 57 equals 97. So first we're going to add 57 to both sides. You're going to show your work directly underneath. These will cancel because negative 57 plus 57 is 0, and we don't have to write the 0. So we still have 7t, and we have 97 plus 57 for a 154. So 7 times something is 154, divide by 7. Now 7 divided by 7 is 1, so I have a 1t, which I just write as t. I don't need the 1 in front. So 154 divided by 7 is 22. So I need to double check this now. So how do we check it? So to check it, we go back to the original equation and we replace the variable with the number we think is the correct answer. So instead of 7t, it's 7 times 22 minus 57 equals 97. And then we're going to follow our order of operations, simplify, and see if both sides come out equal. This works if I get the same number equals the same number. So in this case, that 97, it's already simplified on the right side. It will come all the way down. We need 97 on the left side. So 7 times 22 is 154. So you're basically going backwards through what we did here. And then 154 minus 57, 97. And we end up with 97 equals 97. Our check works, which means we know that the 22 is correct. If this didn't work, well, first of all, we could have made a mistake in our check. But if we didn't, then we know that our answer was incorrect, and we have to find our mistake in the original. Okay, on to number 2. So the steps are shown here. We started out with this equation. The minus 432 disappeared. The number on the right changed. Then the 73 disappeared, and the number on the right changed with the final answer. So what was done to arrive at step 1? So we went from here with the minus 432. It disappeared. So they got rid of this. How do I get this to 0 and get rid of it? I add 432, and you can double check on the right-hand side. If you add 432 to 1101, do I get this? And I do. So this was add 432. That's part A. And then part B, what was done to arrive at step 2? So this was 73 times that. Now, they're going to, again, use the fraction and say multiply. But we're going to look at this as division. This is 73 times y, so we are going to divide by 73. But if you said multiply by 1 over 73, that's the same thing. Okay, on to number 5. So they want us to solve both of these. How do the solutions compare? And see if they are the same or opposites, reciprocals, things like that. So first thing we have to do is just solve these two equations. So let's do that first. We'll do this one here. And as I write these down, I notice, oh, I don't need to solve this. If you look at these, they're the same on both sides. 50x minus 222 is right here, equals 60 equals 60. These say the same thing, they're just flipped. It doesn't matter which side of the equal sign they're on, they're still saying that 60 is equal to this expression. So this is the same thing. So this is going to be A, they are equal. Just because you change which side of the equation the expressions are on, it doesn't change the fact that it's the same thing. So we don't have to do any math on that one. All right, and now we're going to have a bunch of these that we actually have to do the math. So let's run through these real fast. So we're going to minus 42 from both sides because it's a plus 42. That gets it to 0, leaving me 6x and 84. 6 times x means I divide by 6. So 84 divided by 6, x equals 14. We're going to check it real quick. So it's 6 times 14. You take your answer, you plug it in for x, plus 42 equals 126. Always go back to your original. So 6 times 14 is that 84 we had. And when you add 42, you're going to get 126 on the left. And that's equal to 126 on the right. And we're done. Number 7. 31 equals 11a minus 24. Now, the variable's on the right side here. So we're just working the opposite direction. If you wanted to rewrite this as 11a minus 24 equals 31, if that makes you more comfortable to work with, then do it. It says the same thing. As long as this expression goes to the left and then this expression, or the 31, goes to the right, it still says the same thing. So if that just looks better to your eye and you're more comfortable with it, feel free to rewrite it. So I'm going to work with the one they gave me, though. I want to eliminate what's going on here. So I'm going to try and get all of these numbers away from the a, which are on the right side. So the minus 24 is going to have to go. So I'm going to add 24. So it goes away, leaving me just 11a. And then 31 plus 24 is 55. Divide by 11. And a equals 5. Okay, you're going to run your check. I'm going to squeeze it in right here. So 31 equals 11 times, so instead of a, it's 5, minus 24. That's 55 minus 24. And I end up with 31 equals 31. Now, make sure that you actually go through and plug this in the calculator and do the math. So many students will get the wrong answer here, and then they'll run a check and say that their check works, but it shouldn't because the answer is wrong, and it's because they don't actually go back and do the math. They don't plug in that 11 times 5 is 55, and 55 minus 24 is 31. They'll get to here, and they'll say, like, even if this said, say, 67 minus 24, they'll just automatically write 31 equals 31 and move on. So they haven't actually checked anything because they didn't make sure that their answer actually comes out correct. So plug 55 minus 24 in your calculator, make sure you get 31. Don't just assume that it's right. Now, obviously, if you check the answer key and you know 5 is right, then that's kind of a different story. But I highly suggest, especially on your tests and quizzes, when you do your check, make sure that you're actually running the numbers and not just writing stuff down. Okay, number 8. Got this equation. Y is on the left side, and so I'm going to try and eliminate everything from this side. So plus 2 to both sides. And so I get 10. I'm going to divide by negative 20. And be careful because a lot of people would say, oh, it's negative 2, but I'm dividing from top to bottom. It's 10 divided by negative 20. And if you do that in the calculator, it's going to tell you negative 0.5. It's a fraction. Y equals negative 1/2 if you want to leave it like that, or negative 0.5 is perfectly fine. They say the same thing. This simplifies. I'm reading from top to bottom. So you could divide these both by 10. So think about that. If I divide 10 by 10, I get 1. 20 by 10, I get 2, and the negative stays with it. So basically, that's what we end up with. It's not 20 divided by 10, it's 10 divided by 20, so it's a fraction. Quick check, negative 20 times negative 1/2 minus 2 equals 8. Does it work? Negative times a negative is a positive. 20 times a half is 10. When you multiply by a half, you get half the number, and then 10 minus 2 is 8, and 8 does equal 8, so we're good there. Let's squeeze in number 9. So we're going to subtract 16 from both sides. Not 18, 16. I'm trying to get everything away from the b, so this cancels out. So I have 2 equals 5b. I'm going to divide by the 5. And again, that doesn't divide nicely right there. So these 5's cancel, leaving me just b. 2 divided by 5, you could do in the calculator, you're going to get a decimal. It's 0.4, but you can leave it as 2/5. So 2/5 is the answer, but if you put 0.4 because you divide it in a calculator, that's perfectly fine. Quick check. So 18 equals 16 plus 5 times 2/5. If we run 5 times 2/5, let's go over how to do a fraction in the calculator again. So we're going to do 5 times, and for your fraction, it's alpha x. There's that. So the green button and the x next to it, 2/5 and that's 2. So it's 16 plus 2, which of course is 18, and this works out. Okay, down to number 10. Again, with some fractions, first thing you should do is find your variable. It's on the left side, so move everything away from it. Minus 7. That goes away. So it leaves me 3/5 d. We'll talk about what we do with that in a second. Negative 5 minus 7 is negative 12. So to get rid of a fraction that's being multiplied, you have two options. You can divide by 3/5, just like we've done with all of these other ones. The number being multiplied, you divide by it. Or you can multiply by the reciprocal. So we can multiply by 5/3, which is what I'm always going to do. But if you decided to divide by 3/5, you will get the same answer. So we need to understand that dividing by the fraction or multiplying by the reciprocal will get you the same result. The reason is because anything divided by itself is 1. But also when you multiply by the reciprocal, you get 1. 5 times 3 is 15. 3 times 5 is 15. 15 over 15 is 1. So either way, we end up with a 1d, which is what we want. So d equals. And then if you're running this fraction in your calculator, negative 12 times alpha button, the x button, 5 over 3, and that's negative 20. Quick check. 7 plus 3/5 times negative 20 equals negative 5. So first thing we have to do is 3/5, go to the side, times negative 20, and it's negative 12. So it's 7 plus negative 12 equals negative 5. Again, always run it. Don't trust it. 7 plus negative 12 is negative 5. And sure enough, negative 5 equals negative 5. Check is good. Okay, number 11. Got some decimals now. That's not going to change too much. So at first, when you look at this, you might think, oh, wow, these are going to cancel each other out. But be careful because this is a minus 2.4. And so to get rid of it, I'm going to add 2.4 to both sides of the equation. One other place that people struggle is they don't know where to add it. So you find your equation, that's your dividing line. You have to do it once on both sides. Once here to cancel, that's why we're doing it in the first place. Leaves me the 2.4n. And on the other side of the equal sign, 2.4 plus 2.4, that's going to be 4.8. And then we divide, and that goes in twice, so n equals 2. And then you would run your check, you'd plug it in. I'm not going to run the check on that one, but plug in 2, do the math, it'll work. Okay, on to number 12, another decimal. I've got the variable on the left, so I'm going to minus 3.25 to get it out of here. Once on the left side of the equation, once on the right. So 1.06p equals, go ahead and run those numbers. Don't let the decimals bother you. You have a calculator. This is multiplication, so I divide to make a 1p. So 19.61 divided by 1.06. It's 18.5. And then you would run the check. Let's go ahead and run it. So 1.06, instead of p, you're going to put in the 18.5. Plus 3.25 equals 22.86. Go ahead and multiply. Do it in your calculator. Make sure that it actually comes out correct. So I end up with the 19.61. Put these together, it's 22.86. And of course our checks work out right there. All right, last one of these, 13. 200 equals 4 minus 7 over 2m. So another one of these fractional coefficients. We'll either divide by the 7/2 or we will multiply by the reciprocal, 2 over 7. But first we got to start with the 4. Now this is where some students start to get a little confused. They see this minus and they think they have to plus. But this is a 4, right? This is a positive 4. If I add 4 to it, does it go away? No, it would become 8. So I need this 4 to go away, which means I need to minus 4. So you have to look at the sign of this number if it's up front. How do I get it to 0? Don't just fall into the habit of if I see a minus, I plus. If I see a plus, I minus. You have to look at the number you're trying to eliminate. I'm trying to get a 4 to a 0, so I have to minus it. This minus will stay with 7/2 as a negative, so leave it there. Now, we can't just do it on one side, we have to do it on the other, so this leaves you a 196. And now, if we want to get rid of this, you can divide by -7/2. That's one way to do it. So let me show you how that works. 196 divided by negative alpha x for your fraction, 7/2. You get -56. So m equals -56. So why is this just an m? Because you divided a number by itself. -7/2 divided by -7/2 is a 1m. And this, we got that. But let's say, I'm going to bring it over here, 196 equals -7/2 m. A different way to do it would be to multiply by the reciprocal, which is -2/7. You flip the fraction, multiply by -2/7. That also creates a 1m. It's a negative times a negative. It's 7 times 2, 7 times 2. You end up with 14/14. So 1m. And if I plug this in, negative alpha x for your fraction, 2/7, go to the side, times 196. It's -56. I got the same answer. You would plug it in and run your check at that point. Okay, next up is 15. So here now we're going to start writing some equations ourselves from a word problem, and then of course we're going to solve it. So 15. He buys gas for this much per gallon and a drink for $1.50. We don't know how many gallons of gas he got. That's our variable. Whatever you don't know, that's your variable. The total bill was $31.15 before tax. That's just so you don't have to factor in tax, which we will do later on in the book. How many gallons of gas did she buy? Okay, we're going to identify our unknown variable. That is how many gallons. So she spent $2.39, not total on gas, but per gallon. We don't know how many gallons it is, so I'm going to use a G. And up here, I'm going to identify that G represents gallons. So if she bought 2 gallons, they were $2.39 each. You'd multiply it by 2, so on and so forth. She also bought one drink for $1.50. So that doesn't need a variable. You're not going to put a D on it for drinks because she didn't buy multiple drinks. We know she only bought one. It was $1.50. So it was how much she spent on gas plus the $1.50. Came out to a total of $31.15. So now we can solve this equation and find out how many gallons there were. Isolate the variable, so start by minusing the 150. We're still going to have 239G. So 31.15 minus $1.50 is 29.65. So she spent 29.65 on gas. It was 239 for each gallon. So we're going to go ahead and divide. And you see, I don't get a perfect number. And so we're going to round this. And if you notice in the book answer, it says about. That means it was rounded. About 12.4 gallons. Whenever you see this word about, that means it wasn't exact, but pretty darn close. When you're pumping gas, sometimes it's hard to get that exact amount anyway. Makes sense. So we're going to say about 12.4. We're going to round off the rest of it. All right, 16. They give you the information to tell you there's no tax, so we don't have to do that. So she buys 3 chicken sandwiches with a $10 bill. We don't know how much they cost. That's the variable. And she received $1.45 in change. What's the price of a sandwich? So she had 10. She had $10. She subtracted 3 chicken sandwiches. So 3 of them, not $3. Right now this says $10 minus $3. 3 chicken sandwiches. I'm going to put an X. And X equals the price of chicken sandwich. The price. So if it was $2 each, 3 times 2 would be 6, and you do 10 minus 6, she'd have $4 left. Well, they told you it's $1.45 in change left. So she had 10. She bought 3 chicken sandwiches for some price. So we would do 3 times the price of 1 chicken sandwich. That total cost comes off the 10, and it equals $1.45. Now, there's different ways to write this. You also could have done the price of chicken times 3 plus the $1.45 equals 10, and that would be fine. That will work. So I'm going to go ahead and solve this now. I'm going to minus 10 from both sides. Because this is a positive 10, I'm going to minus 10 to get it to a 0. The minus is with the 3, not the 10, so that stays as a negative 3x. 1.45 minus 10 gives me negative 8.55. I'm going to divide by this negative 3. Two negatives will make a positive, so all of these negatives fall off. So my final answer here is 2.85. So one chicken sandwich costs $2.85. 17. 80 students went to the taping of a television program. They filled 7 rows. So 7 rows were completely full. What do we not know? We don't know how many seats are in those rows. So 7 times the number of people in that row. Plus there was 3 students in the 8th row. So the 8th row is not full at all. There's only 3 people in it. So we know that there's 3 extra students. This comes out to a total of 80. P represents students in a row, or seats in a row is fine too. So 7 times the total number of seats in a row that are full, plus those 3 extra students in the 8th row. Put them together, we know it's 80. So we're going to go ahead and solve this. Minus 3 from both sides. This is going to be 77. We're going to divide by 7, and P equals 11. So there's 11 seats in each row. All right, we also had number 18. Solve for n, no checks required here. So that's nice, save you a little bit of work. So 17n plus 38 equals 4. Variables on the left, move everything away. So minus 38, that's going to be negative 34. Divide by the 17, because it's being multiplied, becomes a 1n when you do 17 minus 17, and that's negative 2. B. Variables on the left side, so I'm going to eliminate everything over here, save the number that's attached to the variable for last, so minus 15 to get it to a 0. Do it on both sides of the equation. I'm left with negative 2n equals negative 8. Divide by the negative 2. Negative and a negative makes a positive 4. And last one in this section. We're going to solve for n. That means get n by itself. So what happens here? This is an a. So when I minus a from both sides to get it away from the n, positive a minus a goes away, leaving me 3n. But over here, I can't do 9 minus a and then say it's 6 or a number. So I have to leave it as 9 minus a. And now I need to divide by 3. This whole side gets divided by 3 to get rid of it. So n's by itself, and I'm left with this expression, 9 minus a, 9. My a's and my 9's look the same, so I gotta be careful. Over 3. And we talked about earlier in the book, we can split this into 2 pieces if it simplifies, and it does because 9 divided by 3 is 3. So it becomes 9 over 3 minus a over 3, 2 separate fractions. And the reason we do that is because this right here simplifies. 9 over 3 is 3, whole number 3. This can't be simplified, so it stays a over 3. So these are equivalent. If you left it here, it's equivalent, but we do want to, of course, try and simplify fully whenever possible. And so we're left with 3 minus a over 3. All right, we also had 26, 27, and 28. Going back to the distributive property. Okay, and the reason that I assign these and the reason they're in the review section in this book is because the next section that you're going to do is going to have a lot of distributive property in it. So we just want to review it real quick and make sure we haven't forgotten the special properties that we need there. So when I look at this, I see the parentheses, which I need to eliminate. I'm going to multiply or distribute this number in. The key is to make sure that you're multiplying by a negative 7. So the 7p plus q stay. Negative 7 times the q is negative 7q. And everybody always gets that part right. This is the part people mess up. It's negative 7 times 6. So that's going to be a negative 42. And that's the negative is the part that people mess up. They know 7 times 6 is 42, but they write plus because they see a plus here, but it's a negative 7 times a positive, so it's negative 42p. And we have to simplify this all together. So your p's are going to go together, which is a 7 minus 42. So that's going to be a negative 35p. And then your q's go together. This is a 1q. There's no number, it's a 1. Minus 7, so negative 6q. Fully simplified, you can't put a p and a q together. Ideally, you want to put these in alphabetical order, so p comes before q when you're lining up these terms, but that is not an all-important thing to do. All right, next one. Okay, we have to distribute a negative, and we have to distribute a positive too. So the negative comes to both, becomes negative a. This was a negative b, a negative and a negative is a positive b now. Positive 2 times a is 2a, and positive 2 times b is 2b. Okay, combining now. Start with the a's alphabetically. This is a positive 2 and a minus 1 or a negative 1, so that just becomes positive 1a. This is a 1b and a 2b, so that's positive 3b. You can't put an A and a B together, and so we're done. Last one, 28. Distributing a positive 3, and distributing a negative 2. You don't have to circle it, but I like to do it so I remember it's a negative. So starting here, positive and a negative is a negative 6n, positive and a negative is a negative 15, negative and a negative is a positive 6n, negative and a positive is a negative 10. That's where you're going to make your mistakes. At this point, just put things together. So it's a negative 6n and a positive 6n. That's 0. So those just go away. And negative 15 and negative 10 is negative 25, and that is your final answer.